Good morning, Year 4. Welcome to Thursday's maths lesson. We're going to start this morning with our usual warm-up. 5 questions, 5 minutes. 2 of them are written, 3 of them you might better do more in your head. Have a go at them and try and get as close to 5 minutes as you possibly can. Press pause when you're ready to start and press play when you're ready to hear me talk through the answers. Okay, first question this morning, we're going to look at 3 times 4 times 5. First method I'm going to say would be to multiply the 4 and the 5 together. Okay, so 4 5s are 20, and then I would multiply this by the remaining number, which is 3. So 20 times 3 is 60, or 3 times 20. Method 2, well, you could multiply the first 2 digits together, so 3 4s are 12, and then you could multiply that by the remaining number, which is 5. So that would become 12 5s are 60. Either way are completely okay. It's your choice of method that you would want to use. Okay, the second question we're going to look at this morning is that we have a mystery number divided by 9 equals 2. To solve this, you might want to use inverse operation. Okay, so you could turn it from a division sum into a multiply sum, and you would multiply the 2 numbers that you do know, your known facts. So 9 2s are 18. And if you wanted then to put that back into the number sentence, it would become 18 divided by 9 equals 2. So you could do it that way if you wanted to. That's the way that I would look at it. Okay, next question will be the first of our written questions for this morning, and it's 79 multiplied by 9. So first method, I would suggest setting up short multiplication, abstract method. Line up your columns, and then I would say 9 9s are 81. I'd have to carry the 8 across into the 10s column. It then would be 9 7s, which are 63, plus 8, which would be 71. So our answer then would be 711. Second method, we could partition. So if I partition 79, I would have 70 and 9. And then I would multiply both parts by 9. So 70 times 9 would be 630, and 9 9s are 81. If you recombine the numbers, you'll get 711, which gives you the same answer as over here. Next question, nice and simple. 1/4 plus 2/4. Remember what we've said. When you're adding fractions with the same denominator, the denominator will always stay the same. So in this case, you should only ever add the numerator. So 1/4 plus 2/4 would equal 3/4. Okay, and please look, the denominator has stayed the same. The only thing that's changed is the numerator. And the last question for this morning's warm-up is a straightforward subtraction. Okay, so 6,931 take away 1,859. Now I would use for this, personally, I would use column subtraction, and I would use decomposition method, where we exchange the 10s if we can't subtract. So first of all then, 1 take away 1, nice and easy, is 0. 3 take away 5, we can't do. So we need to borrow or exchange a 10 from the next column. That then comes across and makes this number 13. 13 take away 5 is 8. And then we get 8 take away 8 is 0, nice and easy. And then 6 take away 1 is 5. So our answer then would be 5,080. Okay, so moving on, our learning intention for today is to be able to classify quadrilaterals. So if you think back to yesterday, we were classifying triangles. Today we're going to be classifying quadrilaterals. So a quadrilateral is a 4-sided shape. And if we look at our star words for this morning, we've got classify, which we talked yesterday means the same as sort. We've got quadrilateral, which is a 4-sided shape. We've got square, parallelogram, trapezium, and rectangle. All of those will be important in this morning's lesson. Okay, our in focus task this morning, it says that quadrilaterals, and each of these shapes, every single one of these shapes is a quadrilateral. are polygons with 4 sides. So a polygon is a 2D shape with just straight sides. Okay, there's no curves in any of these sides. So a polygon has 4, these are all 4-sided polygons or quadrilaterals. What we have to do this morning is to look for similarities between quadrilaterals that make you or help you to put them into groups. So our job this morning is going to be to classify or sort these shapes into groups according to their properties, according to something that they might have. Okay, this young lady here has put these 4 quadrilaterals into this box because she said that each of these has 4 equal sides. So she's grouped them, she's put them into properties, into a group that has the property 4 equal sides. And you can see that we've got 1, 2, 3 squares, and we've got a rhombus there as well. Although it's a little bit squashed, it's a bit trickier to tell that one. Okay, so each of these, so she's grouped these shapes because they have 4 equal sides. Now this young man, he did this. He put these 3 quadrilaterals into the same group because he said they've all got 4 right angles. Okay, 4 right angles. And you can see that 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All of them have 4 right angles. Now this child has done this. The shapes, the quadrilaterals, have been grouped according to group 1 and group 2. What I want us to think about is what might the rule be? What might the rule be? First of all, I'm going to ask you to press pause. I'm not going to give you a clue to begin with, but if you need to, I'll give you a clue in a moment. So first of all, what might the rule be for group 1? What might the rule be for group 2? What has made the shapes, all these shapes, fit into this group? And what has made these 3 shapes fit into this group? Press pause now and have a little look, see what you think. Press play when you're ready. Okay, welcome back. For those of you that might need it, I'm going to give you a little bit of a clue. Okay, so here we go. A trapezium is a quadrilateral that has just 1 pair of parallel sides. Now, when we're talking about parallel sides, they are sides that they would never meet. Do you remember we've talked this year about parallel being the same as, say, train tracks? Those train tracks will never meet. They will always stay the same distance apart. So that's a bit of a clue. Okay, a trapezium is a quadrilateral that has 1 pair of parallel sides. Now I'm going to ask you to press pause again. With that information, are you able to now say what the rule might be here? Press pause now. Okay, so if we said a trapezium is a quadrilateral that has 1 pair of parallel sides, I'm now looking at group 2. Now I've got on this shape here, 1, 2. These are parallel sides. These are parallel sides, and they have it has 1 pair of them, this shape. These 2 here are not parallel because if I was to carry these on, let's have a look. Let's see if I can do it. If I was to carry these on, they would meet. So it only has 1 pair. Here, if I was to carry these on, they stay the same distance apart. They would never meet if they're drawn accurately. So this group here has 1, 2, 3 trapezium in it. 3 shapes that are trapeziums. Okay, because they have 1 pair of parallel sides. That's group 2. Group 1 has 2 pairs on each shape. So there are some squares, rectangles, we've got a parallelogram, a rhombus, and another square here. These have two pairs of parallel lines. So that's the difference between these two here. Okay, now it's your turn. There are three shapes here. Which of the following are squares, and can you say why? One of them is a square. Can you say which one and why? Okay, so in this one, the middle one here is the square. If you remember with the square, it has to have 4 equal sides and 4 90-degree angles. That's the property of a square. A rectangle is close. It has 4 rectangles, but it doesn't have 4 sides all the same length. And P does not have any right angles at all. Okay, on this question here, which of the following are rectangles? Which of the following are rectangles? Okay, and this question down here, which of the following are trapeziums? Okay, so I'll let you press pause now, and then we'll come back together and just quickly discuss. Okay, so traditionally we've always, when we're teaching year 4 children, we worry that we talk about rectangles as having 4 90-degree angles, 2 pairs of parallel sides, and 2 pairs of sides that are maybe of different length. So in this case, your rectangle would be this shape here. It has 4 right angles, it has 2 pairs of parallel sides, and it has 2 pairs of sides that maybe are not equal. The trapezium was something we talked about earlier on, and it said that to be a trapezium, it is a quadrilateral that has 1 pair of parallel sides, just 1 pair. So this shape cannot be a trapezium because it doesn't have any parallel lines. This rectangle cannot be a trapezium because it has 2 pairs of parallel sides. This one is a trapezium because it has 1 pair of parallel lines. So the trapezium here is this one. This question here, which of the following are parallelograms? Which of the following are parallelograms? Now, definition of a parallelogram is a shape that has 2 pairs of parallel lines. Okay, so this one is actually a trapezium because it only has 1 pair of parallel lines, doesn't have 2. This one has no parallel lines, so it cannot be a parallelogram. And that just leaves us with the last 2. Now this one has 1, 2 pairs of parallel lines, therefore it is a parallelogram. And this one, the square here, also has 2 pairs of parallel lines, therefore technically a square would be classed as a parallelogram as well. Now the little extension question at the bottom here, are any of the quadrilaterals on this page rhombuses? Okay, and I would say yes, both of these two would be officially classed as rhombuses because as well as having 2 pairs of parallel lines, they also have sides that are the same length. So it's possible to see that shapes can be, they could be more than one thing. Square can be classed as a parallelogram, can be classed as a rhombus. Okay. Right, our independent learning tasks for this morning. Please complete worksheet 2 on pages 105 and 106 of your workbook. Okay, press pause now while you're working. Okay, welcome back. We're going to move into the plenary where we're going to look at the in focus task from the beginning of the session. So if you remember, all these shapes were quadrilaterals. What I want you to do is have a little think, and I'm not going to come back to you on this, but I'm just going to ask you to think, how might you group these shapes? If you remember, the children earlier on grouped them into different sections. Some of them were trapeziums, some of them were not. Some of them were classed as, you could be talking about 90-degree angles, and some were not. So I want you to have a little think, how might you group some of those shapes according to their properties? And I just want you to have a little play with that, and then I will see you tomorrow morning for the last day of the week. Thanks a lot then, guys. Bye-bye.